Okay, so if nobody has a question, what I'm gonna do, I'm gonna at random choose some of the problems. So problem number 1, 2, and 3, they are very similar. Of course, the graphs change, the questions related to the graph is slightly different, but they're similar. So let me do number 3 from the review sheet that's been posted. So I'm going to do number 3 right now. So we're going to use the graph of y equals f of x that you see there and determine the following things. So part A, we want f of negative 2. So for part A, you have to locate what is your x equals negative 2. Remember, this is the function notation. And the function notation, what it's telling me is that my function, whatever inside that parenthesis is the value of x. So x is negative 2. So I go to the graph, locate negative 2 for the x value. Look which point corresponding to that in the graph, which is this one here that I'm marking in pink. That is the point negative 2, comma 3, which means y value for negative 2 is 3. So f of negative 2, which is the y value, is 3. Right? Remember, y is the f of x value, right? All right, so for part B, we want to find f of 0. Now, f of 0, you can see that I marked 0, which is basically where is the vertical axis. So x equals 0, there is an open circle on the top. So let me highlight that. Open circle on the top, and there is a closed circle on the bottom. You have to remember that open circle means that it's not a point in the graph. I just need that, but it's not really part of the graph. The closed circle, yes, it is a point in the graph, and that is part of the graph. So which means f of 0 is the point on the bottom, not the one on the top because it's an open circle, but on the point on the bottom, the closed circle. And that point is 0, negative 1. So the y value for when x equals 0 is negative 1. So my answer for part B there, f of 0 is negative 1. All right, so for part C, we need f of 2. Unfortunately, I wrote too much my graph already, so I'm going to raise a little bit here, the point, and I'm going to use a different color to highlight that. So let's say red color, f of 2, so x equals 2, and then find the y value. So x equals 2 is marked in the graph. The point for that looks like this point right here. So let me count the vertical x. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. So negative 7. So that is the point 2 comma negative 7. So meaning the y value for when x is 2 is negative 7. Okay. All right, so part A through C is all similar things, asking what's the y value, giving a certain x. Obviously, it doesn't say that way, it's used the function notation, meaning you have to understand what is the function notation is, right? So something in the exam, very important, is the function notation. Now, for part D of the problem, we're going to find all the x value for which f of x is negative 4. This time is different. I want an x value giving the y value. So this time I know the y value, which is negative 4. this color doesn't work. So let me put a brighter or black. Black would work. Oh, not that. So this is y, right? Y is -4. So this time I'm going to my graph, look for when I see -4 for y. 1, 2, 3, 4. So -4 for y. I mark that in black. And now I have to find the x value. So there are 2 points that belongs to y -4. So I mark both points, okay? For each of these points, look what's the x value. So the first point on the left, the x value look like positive 1.5, about positive 1.5. And the other, oops, I'm a little bit off there. 1, 2, 3, 4. It's 4. Okay. So I can say here for number letter D that x is about 1.5 and 4. All right. Any questions so far? All right. So for the next 2 parts of the problem, E and F, we're going to determine the intercepts. You start with the x-intercept. Remember, the x-intercept is the point from the graph that intercepts the horizontal axis. Let me use green color for that. So here, in green, I'm marking that x-intercept. So this is the x-intercept. Okay. For x-intercept, it's a little bit to the right of 4. So let's mark that as x equals, let's say, 4.5. I would say less than 4.5, but don't need to be precise, it's approximately. So we have about 4.5, comma 0. That's the x-intercept. Okay. For part F, we have to find the y-intercept, so similar, but now looking for the y-intercept, meaning looking for the point intercepting the vertical axis. And I have to clean a little bit my graph here so I can keep writing. So you're talking about part A? You look for the x value of -2 in the graph and find the y value. So 3 is the y value. You can see I put the point there, right? -2, comma 3 in the graph, pinky point. So the x value of -2, and then you have the y value of 3. So this is a function notation. So when it says f of -2, it's basically asking you the y value for x -2. So that's why you see that. Okay. Now for letter F, we have the y-intercept. So I was cleaning up the graph to just point out the y-intercept. I'm going to mark that in a bright yellow. Let's see, yellow. So this is the point right here, bright yellow. That's the y-intercept. So this is the y-intercept. Now, the y-intercept always start with 0. The question is, what is the y value? It's going to be a -1 there, according to the graph. Okay, so the y-intercept is 0, -1. All right, any other question? All right, so for letter G, we have to find the domain. For letter H, we're going to find the range. And for letter I, we're going to find when f of x is less than 0, which means negative, and write the answer in the interval notation. Okay, so first let's start with the domain. So remember, the domain is the set of all x values. So you're looking for all the points in this graph. And if you look at the graph, there are two arrows, right? One on the left, the straight line on the left, all the way to the upper left, there's this arrow, which says the graph continues that direction, never stop, never turn, going the same way in the same pattern. And on the other side, on the right side, you also have similar. There is an arrow going upwards. That means it's continue the direction, never turn around or back or zigzag. It just continue that way. Now, for the domain, we're looking for the x value that belongs to a point. So if you please note, and let me see which color I'm going to use yellow because I guess that's the only one that's kind of still visible, but not like the other colors that are marked there. So the x value that are all negative, coming from negative infinity, you see they are marked on the horizontal axis. From negative infinity, keep going towards the positive numbers. The question is what's happening to x equals 0. X equals 0, I'm marking there. There is a point for x equals 0, it's the point below. So still we should include x equals 0 and then pass beyond that, going all the way towards positive infinity. Because on the right side, that arrow is going to eventually move it towards the right until cover all the positive numbers. So the domain here is all negatives, all positives, and 0. So domain is everything. So the way we write this for letter G, we're going from negative infinity to positive infinity. Okay, and I have to use both cases with parentheses because it's infinities, right? So we never put square bracket. We never enclose infinity because there is no number to be enclosed there. Okay, questions? So the marked in yellow on the horizontal x correspond to all possible values of x that have a point associated to the graph. If I didn't have a point associated to the graph, I would not mark and it should be excluded from the domain. Okay, but that's the domain. Now let's take a look for the range. Range is about y values. So range is about y values and domain is about x values. Now for the range, for the y values, you're going to read this graph from bottom up. Locate the lowest point, see what is the y for that, and which color I want this. I guess black is still better than nothing then. So the lowest point in black, I mark that. That has a y value. Let me count. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's negative 10 for that. So the y value is negative 10. Now, going towards the positive numbers, the y value is positive. So you can see that we should include everything from negative 10 and then keep moving up. You can see that I have points up to negative 1. And then I also have points between negative 1 and 2 because the points on the right belongs to the graph. So therefore, these y values are also. The point that's open is covered on this side right here. So it has a point. So that y value is included as well. and then you keep going. So it's basically also going to cover all positive values of y. So starting from -10 inclusive towards positive infinity. So -10 inclusive towards positive infinity is the range of the function we see in this graph. Okay, from -10 to positive infinity. All right. I did something very similar to letter I. So here I'm just gonna say that the y values that are negative, right? So for the y values that are negative, you need to tell me which x value give you that, all right? So the answers are on the back, but I want you to think about that. I did very similar with an example in class when y's are positive, when y's are negative, and then you give the x value when that happened in the interval notation. Don't forget to write the interval notation. Again, talking about function notation, which is problem number 4, number 5 as well. I'm just gonna do one of each because they are kind of similar. It's just different expressions. So for example, for number 4, given the expression h of x, and then you have 5x squared plus 5x minus 3. Find h of -1, h of -5, and h of x minus 1. All right. For example, let me do part, A. H of -1, it means that the x value is -1. So using the expression above to calculate that, we do 5 times -1 square plus 5 times -1 minus 3. And now using parameters, you're going to evaluate that. So this is 5 times, now -1 square is just +1. So if the square is +1, and now I'm doing multiplications, I have 5 for the first multiplication, -5 for the second multiplication, then -3. Now 5 minus 5 is 0, so the result is -3. Okay. All right, any questions so far? I'm just gonna mark what to do for number 4. I'm not gonna do it. I'll do something similar about number 5. Sorry guys, my cat decided to visit me at this moment and she's typing stuff on my iPad. All right, so for number 5, oh no, I'm sorry, letter C of number 4. Please note that ask you not what's h of a number, but h of x minus 1, meaning x will be replaced by x minus 1. So it's an expression. We did a couple examples similar like that in the beginning of functional data. And whenever I see x, I'm going to replace with x minus 1. So we have 5 times, and then x minus 1 is squared, and then plus 5 times x minus 1, and then minus 3. So you have to evaluate that. Don't forget to do the distributive property here. Here you have to do the exponent first, and the exponent means x minus 1 times x minus 1. So do that calculation first, wherever is that result, and then you multiply by 5, okay? So there is a little bit of work to be done, but I kind of just hinted up how to do it. After that, don't forget to combine like terms, and the answer again is in the handout. Try your best to not miss any of the order of operations. it implies that you know the order of operations as well. What I want to next is to mention something about number 5. Problem number 5 also is about the function notation. This time is a function called g. And you also have sum with the expression. I want to talk about letter D more specifically. Okay? For letter D, given the expression, right, highlighted there in bright green, g of x is 8x minus 4 divided by x minus 7. And do the calculation we have there. So let's do that. Let's do in red color. So this expression is g of 0. Oh, actually, let me do separately. Let me calculate first g of 0. So g of 0 is, for the fraction, I have 8 times 0 minus 4 divided by 0 minus 7. Now, 8 times 0 is 0, minus 4 is negative 4, on the bottom is negative 7, so this is 4 over 7. So that is g of 0 right here. Now, I also have g of negative 5, so let me calculate that first. So g of negative 5. That means 8 times negative 5 minus 4 divided by negative 5 minus 7. So g of negative 5 is, now 8 times negative 5 is negative 40 minus 4. And then we're going to divide it by negative 5 minus negative 7. So that's negative 12. I'm sorry, negative 12. So g of negative 5 is negative 44 divided by negative 12. I know at least division by 2 we can do, but maybe even better than that. So the result is going to be a positive number because it's a division of 2 negatives. Let me use my calculator. So that's the same as 44 divided by 12. I know divided by 2 is 22 divided by 6, and still can divide it by 2. Okay, so it's not going to be an even division. So this 44 divided by 2 is 22. 12 divided by 2 is 6. And now divide one more time by 2, it's 11. And then 3. So 11 over 3. Why I did these two parts. So this is not really the answer that I'm looking for, but I need that to calculate the answer. So now back to this. G of 0 plus 2 times whatever g of negative 5 is, we have g of 0, which is 4 over 7, plus 2 times g of negative 5, which is 11 over 3. So now all I need to do is to do that addition of fractions. So I have 22 over 3. To add fractions with different denominator, find the LCD. So the LCD is 21. So first fraction, I'm going to multiply top and bottom by 3. The second fraction, I'm multiplying top and bottom by 7. Because I needed the same denominator. So now both of them have denominator 21. So the top of the first fraction on the left is 4 times 3, 12. And 22 times 7 is 154. The next and last step is keep the denominator and add the top. So we have 12 plus 154, 166.